Hello everybody and welcome to this tutorial. Today I will be talking about filters, to be more precise about protocol filters. I will mention some of the protocols that we've talked about a bit before, but we'll get into more detail now, and I will also mention and explain some of the newer ones. So you have the option in Wireshark to filter all traffic via a specific protocol, although those are very loose filters and they will give you a lot of information. You want to downsize, you want to trim that information further, so we will at later stages apply some other filters to it as well. However, before we begin with it all, I just want to explain to you what you are seeing at the moment. So in the upper left corner you have a filter bar, and in the field you can type in whatever you want, but there we will be typing in our filters. But let me just show it to you. So whatever, you see it is displayed there, it is marked as red, which means it is not a valid filter. But in the bottom right corner it is retyped and reshown here, so to say. This thing that you're seeing in the bottom right corner, this is not a part of Wireshark or anything of a kind. This is just a magnifier app that I've gotten and that I've installed that comes in with KDE or something like that for Linux. And here you will be able to see with greater clarity what I'm going to type in the filter field. This I've done primarily because I can't resize it. It is the way it is, and the letters are a bit small from the perspective of a viewer who is watching this tutorial, so you will be able to see whatever I type there down at the bottom right corner. Excellent. Now that we got that out of the way, we can go ahead and start using our very first protocol filters. So as you can see at the moment, there's a certain variety of protocols that are being displayed here. You have DNS traffic, TCP, TLS, this is encryption, and you have ICMP, which is ping. We will deal with that separately, but for the time being what I want to show you is this bottom bar where information is displayed in regard to the amounts of packets captured and the amounts of packets displayed. So you see that the numbers are exact, and next to the displayed packets you have a percentage of total packets displayed. So if we just go ahead and go to the filter field, type in TCP. There are some other options below it, but we're just going to press enter for a regular TCP filter. And if we go down back again, if we take a look at how much, what percentage of the total amount is being displayed, you see it's 83%. Now, you might think, oh, excellent, we've downsized the information that we need to process by 20%. But let me tell you, that is nothing. 4,000 packets here is a fairly low amount, primarily because I don't have a lot of active internet connections at the moment while I'm doing this tutorial. But if I was on the net, if I was doing something, if my DNS server was up, if I was communicating with other computers in LAN, the number of these packets would jump to hundreds and hundreds of thousands, eventually into millions, etc. I have no doubt that after a while it would the live capture process would probably crash my computer because I would simply run out of RAM. Therefore, we're going to go ahead and try a different protocol filter aside from TCP. So these are some basic protocols which you do need to be acquainted with. So we're just going to type UDP. We didn't talk about it much. I think I've just mentioned it or something of a kind before, but UDP is a user datagram protocol, and I will explain it to you in a second, but I just want to show to you packets captured and packets displayed. So this is displaying only 10% of the total content, primarily because there isn't that much UDP traffic in general. Not unless you're using some sort of a VoIP applications, or like Skype. If you were using Skype, you would have a ton load of UDP traffic. However, as you can see here, it's only 10%, and 10% is something manageable. It's something you can deal with. It is fantastic. You can see that most of the traffic out of that 10% are DNS requests. So I don't know, here you can see I'm connected to Google Drive, Docs, Mail, etc. These are my DNS requests that I have made, and DNS, by the way, functions over UDP. I will talk more about it in a moment, but for the time being, we're just going to stick with it. UDP, unlike TCP, does not guarantee delivery at all. It just packets just go through it. It sends packets, and there's no guarantee of whatsoever for you that the other side will receive them. That's why it's not very reliable, especially if you're using it for some sort of chat applications, for messengers or something of a kind. But it is extremely fast. It is much faster than TCP, and that's why some other things like DNS servers or VoIP applications do tend to use them. But whether an application uses a DNS or whether an application uses TCP or UDP protocol, that's purely left to the person developing the application. It is not a mandatory requirement by any means. Okay, so next up, I'm gonna do some DNS filtering. And there are two ways in which we can do that. The first one is relatively obvious. So you can go ahead, click on the filter field, and type in DNS. Let me just show it to you down there. Yep, there we go. Press enter, and it's going to filter out all DNS traffic. So you can see all the queries on the right side. You have Google Docs, Docs again, Google.com. I don't know, I'm going to open some other things in my browser in later tutorials when we do some real-time exercises. But for the time being, you can just see what it is and how the filter works. There's also another way of doing this, as I said. Since we know that DNS servers, they function on port 53, and all queries are made on that port as well, and we also know that DNS functions over UDP, although it can function over TCP as well. So we can just do this: UDP dot port. Oops, it escaped a bit, so you can see it here better. Dot port equals 53, and there we go. We can also spoof DNS traffic like this. We can monitor it in such a way by port rather by just typing in DNS. I don't know, DNS, it's a lot simpler to type in and all that, but this is a much more precise thing to do. In addition to this, you can also say, for example, or, you can put in a logical or, and you can type in TCP dot port equals 53. So this is also a very nice way of doing things. It makes sure that all traffic, be it UDP or TCP on port 53, is displayed, which in my case is 5% of total traffic that goes on my network at the moment. This is primarily because I have stopped the capture, and during the capture I have not made that many queries. I have not opened pretty much any websites or anything of a kind, just that which was already opened in my browser stood like that, and a few pages that I refreshed, but nothing much. So 5% of total traffic, that is it. Okay, so next up we have ICMP, more commonly known as a ping. So it is a fantastic tool, it is a fantastic protocol, a fantastic utility to test and troubleshoot connections. So basically, here's an example. You know, one of those days when you've opened up your browser and no page wants to open. Basically, you're uncertain whether you have connection issues or whether it's browser issues or something of a kind. Well, you can solve your dilemma with a ping by simply doing this. So you open up your terminal. I have mine here, so you just go ahead and go to a free tab. I'm just gonna lower it because I want to show you how these things happen. And before we actually start any ping processes on the terminal, I would like my filters to only capture ICMP packets. I don't want it to show all these things because it's going to be confusing and we're not going to be able to see them. So I'm just going to go ahead and type ICMP, and that's going to be my filter. Press enter. There you go. The screen is clear. There are no ICMP packets, primarily because we have not transmitted any. So we go ahead and type in ping google.com. When I press enter, just watch what happens. Watch how many packets are gonna come out. And there we go. It's starting. So you see protocol, ICMP, ping request, reply, request, reply. It just goes on and on and on. If you're using a Windows machine, this is going to repeat 5 times, if I'm not mistaken. If you're using a Linux machine, it's going to repeat God knows how many times. But you can specify the amount of pings you want to send. In any case, as I said before, a fantastic way to test out your connection. So you see, this is just a communication between me, and I am 192.168.1.2, and the Google server, which is, well, not Google server, but yeah, it basically is a server, but this is an IP address of google.com, so 208.117.229 and 219. I have pinged it. I now know that I have internet connectivity, that I have the ability to reach the outer world, and if my browser won't open a page or something like that, it could be that there's something wrong with the browser, or that a firewall in my local network is preventing me. A proxy server, that could be a proxy server that's preventing me to exit on the net. In any case, that would be it for this tutorial. Here I will wrap things up, and in the next tutorial we will be dealing with IP string and port filters, so we'll be able to see how those function, and after that we should be able to do some live exercises. I'll make a setup for you guys, so we'll have more than one machine and we will see how they can communicate in between each other, and more importantly, at later tutorials we will see how we can actually capture that traffic, how we can analyze it and get some useful information from it. In any case, I bid you farewell, and till next time.